So this one says we have a 3 kg trolley, which is at rest on a horizontal frictionless surface. A constant horizontal force of 10 newtons is applied to the trolley over a distance of 2.5 meters. Okay. And then they say, when the force is removed at the point P, the trolley moves a distance of 10 meters up the incline until it reaches the maximum height at point Q. When the trolley moves up the incline, there is a constant frictional force of 2 newtons that is acting on this trolley. There is no applied force, but there is frictional force. And frictional force is not the only one. There is also the parallel component of the gravitational force. Well, that's fine. Now, the first question says, write down the name of the non-conservative force that is acting on the trolley as it moves up the incline. Okay. So yeah, we know that it's the frictional force, which is the non-conservative. That is nice. Then the next one says, draw a labeled free body diagram showing all the forces acting on the trolley as it moves along the horizontal surface. Well, I think you know how to draw the free body diagram by now, so we are not really going to entertain this one, all right? No. But if you should know, it's just the applied force, which is a horizontal force. And since it's on a surface, there is normal force. And since it has mass, then of course it's going to be gravitational force as well. Then they say, state the work energy theorem. Wow. So now you have 6 marks, which you didn't sweat in order for you to get it. Not bad. Then the next one says, use the work energy theorem to calculate the speed of the trolley when it reaches the point P. So what are they saying? The final velocity for the horizontal motion, which will be the initial velocity for the motion along the incline. Okay? Well, that's fine. So let's go ahead and quickly destroy this one. I can't find the group chat now. Oh, this is it. Right. So we say, okay, according to the work energy theorem, when a net force acts on an object, the net work that is applied on this object is equal to the change in the object's kinetic energy. So this is what we're going to say. That's fine. Now the question is, what is the net force when the trolley is moving on the horizontal plane? Well, it's just the applied force. So you can put it nicely and say, what is the question asking from us anyway? Well, they're asking us to find the speed, the velocity at the point P, okay? So it means I'm on a right path. So here we just come and we expand the work energy, not really the work energy theorem, but the net work. Then we say, well, our net work is going to be the net force times the displacement, and this is multiplied by the cosine of theta. And now we understand that there is no need for us to write it in full. Well, we can simply say the following, okay? Then we say, what is the magnitude of the net force? Well, it's 10 newtons. What is the displacement? It's 2.5 meters. What is theta? It's 0 degrees. Why? Because the net force, which is the applied force, is in the same direction as the displacement. So if two vectors are in the same direction, the angle between them is just going to be 0 degrees. All right? Now we come and say, but the mass of this trolley is 3 kg. And what is the final velocity? It's the one we are looking for. But initially they told us that it's going to be at rest. Okay? If you go to your calculator and say 1/2 multiplied by 3, well, you simply get 1.5. And if you say 10 multiplied by 2.5, and you divide this by 1.5, then you find that VF squared is simply going to be 16.66666, so many 16s there, and you'll have 7 at the end. And if you find the square root on both sides, you find that the velocity at the bottom of the incline will be 4.0824 that. And then you say, well, to 2 decimal places, it will be this much. Yes, you just state your work energy theorem. Then you say, but how do I define the network? Well, this is how the network is defined. And also your change in kinetic energy, that's how it is defined. And you do your substitutions, and your happiness is complete. One. The last one says, calculate the height h that the trolley reaches at the point Q. And this is for 5 marks. So now we know the velocity at the point P. Okay. But then remember what they said to us in the statement. I think they said it reaches the maximum height at point Q. Right. So we know that at the maximum height, the velocity is 0. So they were just telling us that the final velocity at the point Q will be 0. So we know the initial velocity, the final velocity. Therefore, we can find the change in kinetic energy. Now, we also know the initial height. At the point P, the height above the ground is actually 0. And at the point Q, the height above the ground is h. Okay? They also told us the magnitude of the frictional force. They said to us the frictional force here is 2 newtons. And what is a frictional force? Well, frictional force is a non-conservative force. And we also know the displacement. They told us that the trolley moves upwards and it covers a distance of 10 meters on the inclined plane. So we know the magnitude of the force. We also know the magnitude of the displacement. We can definitely use the formula for the work done by the non-conservative force and find this height. So let's go ahead and destroy it without showing any signs of mercy, of course. So remember, they don't come easily, these things, but they definitely come with a lot of practice and understanding. And studying as well. You can't skip the studying stage. Now we say, well, the work done by the non-conservative forces is equal to the change in potential energy plus the change in kinetic energy. All right. Then we say, but what is the non-conservative force in this case? Well, it's actually the frictional force. So you can take your frictional force, multiply it by the displacement, and then say the cosine of theta like that. For your change in potential energy, well, you're simply going to say it's the final potential energy minus zero, right? I hope you're not offended if I say final potential energy minus zero, because remember, the initial potential energy is zero because the initial height is zero. The point P is just on the horizontal plane. Then we come back for the change in kinetic energy. Well, we say the final kinetic energy is going to be zero because this box reaches its maximum height, which means the final velocity is zero. So the kinetic energy will also have to die. Okay? Well, that's fine. And then what can we say from this point further on? Well, we now talk about the initial kinetic energy, which is 1/2 mvi, and then you say squared. Then you come and say the magnitude of the frictional force. They gave it to us as 2 newtons. The displacement is 10. And of course, the angle has to be 180 because the frictional force is in the opposite direction to the displacement. The mass is given to us as 3 kg. Acceleration due to gravity, they don't need to tell us. And the final height is h. Then we say minus 1/2 into the mass. The initial velocity, which is the velocity at the point P, the one we previously calculated, it's going to be, if you still have it in your calculator, then it's nice. Please put it exactly as it is into your calculator and just square the entire thing so that you don't get a compromised answer. All right. Now let's check. If you go to your calculator and plug in this entire expression here, so you have 1/2 into 3 multiplied by this thing all squared. You see, you get a solid 25. And here when you say 3 times 9.8, well, you get a solid 29.4. And of course, 2 times 10, well, it's 20. Cosine 180 is -1. -20 plus 25, it is 5. And this is equal to 29.4 h. And when you say 5 divided by 29.4, well, you find that your height is simply going to be 0.17 meters. And this is your height above the ground, and your happiness will be complete. So for this one, there was no point in using the work energy theorem. No. Your net work equals change in kinetic energy was not going to help you because that one, it only focuses on what is happening on an incline. It doesn't consider this height, no. It's just considering the motion along the incline. So this was the best way out.